Hey Dakota, this is Miss Tracy. So we're going to go over those problems that you needed help with. So let me, here's just the first one. Use unit multipliers to convert 11,111 cubic miles to cubic centimeters. So the keyword here is cubic. So we are going from miles cubed to centimeters cubed. So that's 11,111 miles cubed. Now we've got to convert this to the reference that we use to cubic references. So the way you do that is just by cubing every one of these, all the numbers and all the units of measure, and then that makes it easy to cancel the cubic unit of measure. So we're wanting to cancel miles cubed, so we're going to put that in the bottom. So 5,280 cubed feet cubed. If we don't cube it, then what happens is we have to write it 3 times. This is the same thing, it's just writing it faster, writing it in fewer steps, which we know mathematicians are lazy, so that's what they want to do. So then that cancels miles cubed. It's a much easier step than having to write this out 3 times, right? So now we want to go from feet cubed to inches. So we're going to write 12 cubed inches cubed over 1 cubed foot cubed. That cancels the feet cubed. Now we're going to go from inches to centimeters. So 2.54 cubed centimeters cubed is 1 cubed inch cubed. So what we're doing is we're saying 1 inch over 2.54 centimeters times 1 inch over 2.54 centimeters times 1 inch over 2.54 centimeters. We're writing all of this in one space. That's what all these little cubic exponents are all about, because 1 times 1 times 1 is 1 cubed, and inch times inch times inch is inch cubed. 2.54 times 2.54 times 2.54 is 2.54 cubed. Centimeters times centimeters times centimeters is centimeter cubed. So this is keeping us from having to write each one of these 3 times. And that's why we cube everything. Otherwise, we would have to do that to solve the problem. So that cancels inches cubed. And now we are down to the unit of measure we wanted to go to, which was centimeters cubed, right? That's where we are. So now we just have to write this out. 11,111 times 5,280 cubed times 12 cubed times 2.54 cubed centimeters cubed, because everything across the bottom is 1 times 1 times 1 times 1. And we know it doesn't matter however many times you multiply 1 times itself, the answer is still going to be 1. So this would all be over 1, making it a whole number. So just write it out like this and you're done. Right? It says don't try to multiply it out. It's too big for your calculator. You would not get an answer. It would give you some error message. So this is what you want to put into Jupyter. All right, that was the first one. Let's look at the next one. All right, this one says to write the conjunction that describes this graph. Specify the domain. So the domain here is going to be reals because it's including the numbers between the integers. Okay, so it's including 1.5 and 2.5 and 2 1/3. So whenever you see a line, the domain is always reals. Okay, when you just see dots, that's when it's integers. Okay, all right, so because it only wants the whole numbers, the positive and negative whole numbers and 0. Now, if all it included was the positive integers, then you would say, or the positive whole numbers, you'd say positive integers. If it included 0 and the positive numbers, then you would say whole numbers. If it includes negative and positive and 0, then you would say just integers, all the integers. If it was just negative, you would include just negative. So you have to look at, what numbers are included. That is the domain. Domain is the numbers, the number type that's included. And remember, all of this, the domain comes from where we talked about reals is all numbers, and then you have irrational and rational, and then you have integers, and then you have whole numbers, which is 0 plus the natural numbers, which are the ones we count with, 1, 2, 3, 4, 5. Whole numbers is 0 plus the natural. So whole numbers includes the possibility of having nothing. Whereas natural numbers, if you have a handful of M&Ms, you start counting 1, 2, 3, 4, 5. It doesn't include 0 as a possibility because you're not counting with it. So natural numbers are sometimes called counting numbers. Whole numbers means that it includes the possibility that your hand might be empty. Integers includes the possibility of negative whole numbers, opposite of the positives. And then rational numbers includes the numbers in between whole numbers, like 1.5, 1.4, those types of real values. That's why we call them reals, because they're real values. Irrational numbers are just those decimal numbers or symbols that we use that don't ever end and don't ever repeat. We'll never have irrational numbers as a domain. We'll never say rational as a domain either. Instead, we would just say reals. Because we can't specify irrational versus rational on the number line, because in that number line there are also the decimals that never end, right? We know they fall in here somewhere, but they're just a never-ending, non-repeating decimal. So we would never specify between rational and irrational, just be reals. Then it would go to integers as a domain. Then we go to whole numbers. Then we go to natural numbers. But typically we would just say positive or negative integers, right? But that's where domain comes from. It comes from your categories of the type of number that is included in your number line. So when you see the line, it's always reals because it's including all the numbers that are possible. And that's all numbers. All right, so now let's actually talk about the conjunction. So all you need to do to write a conjunction is you look at your numbers on the line. Which ones are indicated? I have a -2 and I have a +3. X is what is between these two. X is what is graphed. It's the set. Right? So it is specifically the black line with the circles. So all you have to do now is look at the circle, and if it's not filled in, it is a less than sign to the X. And then you look at the last one, and if it is not filled in, it's a less than sign, but because it is filled in, this is a less than or equal to, because the 3 is included. That's what the filled in circle means. This is your conjunction. So you would write -2 is less than X, which is less than or equal to 3. All right, writing the conjunction itself is fairly easy. You just do what I just told you. That's it. Okay, so those are the steps. Write the number on each end, put X in the middle, and the sign is always going to be less than or equal to. Not filled in, it's less than. Filled in, it's less than or equal to. Pretty straightforward. Okay, and that is determined by the circle on each end. All right, so let's do the next one. All right, this one says to factor completely. So one of the things it's wanting you to recognize is that there are there's this operation here that you're supposed to distribute within each term, but it's duplicated. So that duplicated binomial is a factor, right? It's a factor. It's just like if you had looked at this and 21x, right? 21x. X is a factor. It's 21 times x. Well, the x in this case is x plus y in parentheses. It's being multiplied times the 21. It's being multiplied times 10a. It's being multiplied times a squared. So that is your first factor that is common to all three of these terms. We're going to take it out. So x plus y, if we remove that, then what we have left is a squared plus 10a plus 21. We're dividing each term by this factor. So because if you were to reverse this and say x plus y times a squared, that's what you get. X plus y times 10a, that's what you get. X plus y times 21, that's what you get. So there's a distribution that you're just not doing yet, and before you do it, you're taking it back out. All right, so when you see those, just take them out first. Put them to the side, and then put what is remaining within parentheses. Then you factor this. So now we have x plus y, and we're going to turn this into two binomials. So we know the factors of positive 21, that would equal a positive 10, would be 7 times positive 7 times positive 3 gives us a positive 21, and when you add them together, it equals positive 10. So those are going to be our factors, a plus 7 and a plus 3. And those are the things you're going to put in each one of those three blanks. This is a blank, this is a blank, and this is a blank. Okay? All right, next problem. All right, here's another factoring problem. So you've got to learn how to identify when you have something that is extra, just like the x plus y in the previous problem. What we have here, we have an extra x here because we know we can't factor an x cubed. We can only factor an x squared. Well, that's here, but we're supposed to have a term that doesn't have an x. So we have an extra x in everything. So that's our first factor that we take out. So when I take x out of x cubed, I get x squared. When I take an x out of this 12x squared, I get 12x. And when I take an x out of 32x, I have just 32 remaining. So this is times each of these. If we do that multiplication, it takes us back here, right? So we know we did this right. So now I am going to turn this into a factored binomial. So I'm going to look at 32, and I'm going to ask myself what two factors that give me a positive 32 when combined equal a positive 12. And that's going to be positive 8 and a positive 4, because 8 times 4 is 32. But when you add 8 and 4 together, you get a positive 12. So it's going to be x plus 8 and x plus 4. And then you're going to put x in this first blank, x plus 8, and then x plus 4 in that third blank. And that's how you're going to answer that problem. All right, so let us look at the next problem. Okay, so this is what we call a perfect square, but it's not in the right format because the minus sign has to be in the middle. So we rewrite it 2x squared minus 72k squared. Now, when we look at that, we look at x squared and k squared. We know we can factor those, but 2 is not a perfect square and 72 is not a perfect square. But because I know my times tables, I know that 2 times 36 is 72, and 36 is a perfect square. So I'm going to take out a factor of 2 from both of those. So that's going to give me 2 times x squared gives me 2x squared, minus 2 times 36 would give me 72. And that's my first factor. Now this is a perfect square. I know how to factor this. And it's always the same format. It is the x minus y, x plus y. Always, always. And x is the unsquared version of this term, and y is the unsquared version of this term. So that's all I'm going to do. I'm going to say 2, say x minus 6k, x plus 6k. Because I know if I multiply negative 6k times positive 6k, I get negative 36k squared. Right? And then that times this gives me this. So that's all you're doing. You're following this pattern, but you've got to get to a point to where it looks like this first. Oh, and I don't know what happened. Oh, it quit. GoodNotes has been quitting on me here lately. I don't know why. I think that it needs an update or something. Here we go. We're back to where we were. So, it's this, right? If you can get it to this point where this is a perfect square minus another perfect square, then you always can do this. But sometimes you have to factor stuff out to get there. And that's what we had to do with this problem. So let's go to the next problem. All right, so this problem says, what is the y-intercept point for the equation y minus 2x equals 1? So we know that the equation of a line is y equals mx plus b. Plus b is the y-intercept where it crosses the y-axis, right? We know that. So we've got to put this into this format. That means we got to move the x term over to this side. So we add 2x to both sides, and that gives us y is equal to 2x plus 1. Okay, plus 1 is the same thing as the plus b. That's our y-intercept. So when we have a y-intercept, the x is always 0, and the 1 is that point on the y-axis where it crosses. So you would put in here 0, 1. Okay, that's all you ever have to do. You take this, put it here, and you put the 0 for the x term. Because any point on the y-axis is at the 0 on the x. That's the origin for the x line, for the x-axis. All right, next problem. Okay, so here an urn contains 8 gold coins and 7 silver coins. It gives us a total of 15 coins. A coin is drawn at random and not replaced. So that's important. Another coin is then randomly drawn. What is the probability that the first coin will be gold and the second coin will be silver? So there's our probability statement. So now we're going to apply that. So if the first draw, on the first draw, everything looks like this. We have 8 gold coins and 7 silver coins for 15 total. We want the first one to be gold. So 8 out of 15 is gold. That's our chance of drawing a gold coin on the first term. But it is not replaced. So that changes our total. So now we have 7 gold coins because we kept that first gold coin out, and 7 silver coins for a total of 14 coins. Right? So when we want to draw that silver coin out, there's 7 out of 14. There's 7 silver out of 14 total. So that gives us a probability of 7 out of 14, which would go here. However, we know this really just can be reduced. Whenever you can reduce a fraction, reduce it when it makes sense to. 7 out of 14 can be reduced to 1/2. So I'm going to just rewrite this problem where 7 out of 14 is reduced. That makes my life a whole lot easier. Now I'm going to multiply. 8 times 1 is 8, and 15 times 2 is 30. Well, I know I could have reduced this here, and I didn't, just because I wanted to show you on the back end. We're going to reduce this by 2, and we're going to reduce this by 2. So 8 divided by 2 is 4, and 30 divided by 2 is 15, and that would be your answer. I could have just as easily said 4 times 2 and taken out the 2's, and then 4 times 1 would be 4, and 15 times 1 would be 15. But I didn't. I just went ahead and reduced the fraction to show you the first step. But either way is the same answer. So 4 out of 15 is your response. The key that you've got to look for is where it says not replaced. That's without replacement. So it changes the quantities that you have in the urn for the second draw. And if you had another draw after this, you would have to adjust for keeping that silver coin out. So it's all about what's in the jar. If it says it's replaced, then nothing changes. If it says it was not replaced, it was kept out, then it changes the quantities and you have to adjust your math. All right, let's look at the next one. Okay, so here we have 3 lines to solve for. Now, just because, well, let me just go in order. Let's just start with A. So here we know that the format of a line is y is equal to mx plus b, right? And most of the time we can start by just looking at where's that b at, and that b is where it crosses the y-axis. And for this line, for A, we have it crossing at the 7. So we have y is equal to mx plus 7. That's our first step. So we see that right there. That's a positive 7. Now we need to worry about the slope part. So with this, we need to trace that line of where's the slope. It goes up and then it goes over, right? So it's positive because it goes up and over. So it goes up 1 space and it goes over 2 spaces. So our fraction is 1 because we put the up and down on the top, that's the y-axis, and we put the 2, which is the x-axis on the bottom. That's our slope. So I'm going to put right here, m is equal to, because m is the letter we use for slope, y is equal to 1/2 x plus 7, which you got perfectly. So good job. I really didn't explain that one. I didn't pay attention to my answers down here, did I? Okay, so, and also I would say on C, you have -2 over 2 is x. You're almost there. You're almost there. -2 over 2 equals -1. So we could write y is equal to -1x minus 5 for C, but we usually don't write that invisible 1. So y is equal to -x minus 5 would be the better answer. This would be probably marked correct. I think I put it in the system also, but this is the better answer because we don't write that invisible 1 usually. But either one should be taken. So that would be your C. The problem you're having, I think, the bigger problem is with B, and that's because of the slope of the line. You can't see where it crosses the y-axis. So we have to do actual math to figure out what our plus B is. And in order to do that, instead of getting the plus B first, we have to get slope first. So we're going to draw our little line, and it's going down and then to the right. So it's a negative slope. So 1, 2, 3, 4. It's a -4 because it's going down, and then 4 over 1. -4 over 1, which equals -4, right? So we start by, this is for B, we start by putting that slope in. Y is equal to -4x plus B. Now we're going to sub in a point to find the B. So we just have to figure out a point. Here's a point right here. It's given to us. So that is 3 on the x-axis and 4 on the y-axis. So our point is 3 and 4. So we put 4 is equal to -4 times 3, because that's the x point, plus B. We say 4 is equal to -12 plus B. We're going to add 12 to both sides so we can solve for B. So this cancels. 16, positive 16 is the value of B. So now we can go up here and rewrite this as y is equal to -4x plus 16. And that would be the answer for line B. Okay. Whenever you cannot see where it crosses the y-axis, find the slope first, put that into the problem, then find a point and sub it in to find your B value. And then you can put that back into the equation and correct it. All right, so that's the step you needed for that one. All right, this one says, this is the next problem. Graph the equation 5x plus 3y equals x. So we know we've got to use y is equal to mx plus b, right? So we get y by itself without a coefficient. So we're going to subtract 5 from both sides. And that gives us 3y is equal to x minus 5. Now we have to divide everything by 3 to get y by itself. So that gives us y is equal to 1 over 3 x minus 5 over 3. Okay, this is a hard number to graph. Sometimes it helps to put it back into mixed number form. Even though algebra really hates mixed numbers, we can do that when we need to really see the numbers. 1 and 2/3. So negative 1 and 2/3. So that's what we're going to find. Negative 1 and then about 2/3 down. So right there. Now we're going to look at our slope, and the slope is positive. So we're going to go up 1 and over 3. So go up to this 2/3 mark here, the negative 2/3 mark, and go over 1, 2, 3. Go up again to the same position here on the next block and go over 3 more. And then there's your line. And just draw it as well as you can. Okay. Now, the other thing that you can do when you have a weird little thing here like this, the other thing you can do is go back to pre-algebra and use your table. Remember the tables that we used to do? Where you would put your formula in here, 1/3 x minus 5/3. And then that would give you your y value. You start with a 0. So this would be 0 minus 5/3, right? So that would be negative 5/3, which we turn into a mixed number, negative 1 and 2/3. Okay, that's your first point that you have. Then, remember, we always said use a multiple of the denominator. That helps the math be easier. So let's use 3. So 1 over 3 times x would be 3 over 3 minus 5 over 3, which would be negative 2/3, which if you look, this point right here is about 2/3, right? Here. So negative 2/3 is not quite to 1. It's about 1/3 away from 1. So that would be about right here. And that would be on the 3. So 3 and negative 2/3, which is what this point is. Right? And this one is 0 and negative 1 and 2/3. So, all right, then we pick the next multiple of 3, which would be 6. We put that in here. It would be 6 over 3 minus 5 over 3. So it'd be a positive 1 over 3. So again, right here, positive 1/3 is the y value. So this would be 6 and positive 1/3. Okay, so that's what you're doing. You can either do it visually, where you can just kind of guesstimate it, or you can do it with a table. And with, like I said, with weird ones like this, table is usually an easier way to go, because then you don't have to try to guess about, well, is this one up or is this, where's this falling? Then you can just go by your points and then just be close, right? Miss Anna and I are not going to expect perfection. We've never expected perfection when grading lines. What we will do is look at the points and see if they're about in the right spot. And as long as you draw a line that tries to connect them, then that's all we're looking for. We're looking for the fact that the line is the answer, and the points just help you find that. All right, so let's look at I think you've got one more. Let's check. Okay, and here's your last one. So an urn contains 5 orange marbles. So we've got 5 orange marbles and 6 blue marbles. So 6 blue marbles. So that gives us a total of 11 marbles, right? 2 marbles are drawn at random. What is the probability the first one's orange? So the probability that the first one is orange and the second one is blue if the marbles are drawn without replacement. That means we're not going to put it back in. So if we take an orange one out, right? First, let's do the orange draw. The orange is 5 out of 11. There's 5 oranges out of 11 total. So 5 out of 11. So we take an orange one out. So we subtract 1 from the orange, and that makes 4 oranges and 6 blues for a total of 10 marbles, right? So now we're going to look at the blue. If we want to draw a blue one, it's 6 out of 10, which we know we can take that fraction, 6 out of 10, and that would be equal to 3 out of 5. So we're just going to reduce it to make life easier. So 3 out of 5. So what I see in looking at this, though, is that we can cancel the 5s, right? That makes it easier. So then we just have 3 out of 11 as our final answer. Okay? But you have to, when it says without replacement, again, like that other problem, you've got to adjust the quantity that's in your urn or your bowl or your bag or whatever it is that you're drawing from, because it changes the quantity, the total quantity, and you just have to adjust it to make it work, to make it what it's supposed to be, or to reflect reality, I guess is the best phrase. And that's all I think that you had. If you have any more questions, please feel free to ask. Hopefully we'll see you again this week. I hope you're feeling better. I extended an olive branch to Kyla Ford. She lives out there near Star Landing Road, and her mom is having some issues, so she might be riding with us. And if she does, her mom's just going to drop her off at the house, just like you get dropped off at the house. So, just a heads up, we might have one more with us. We might not. It just depends on the week. And if she's having, that's Kita's daughter, Kyla. She's so sweet. So I know adding her to our crew would just be, a positive thing. So anyway, just going to give you a heads up that we might have some more company. We might not. We'll just see. All right. That's all I got for you. And like I said, hope to see you next week, and peace out.